Hey everybody, welcome back to my channel. This is WireDogSec, back with another video for you guys. Today's video, we are continuing on with SOC Level 1 Learning Path. This is the Network Security and Traffic Analysis module, and this is the Snort room. Learn how to use Snort to detect real-time threats, analyze recorded traffic files, and identify anomalies. Now, before we start, be sure to go to task number 2 and start up the virtual machine here if you are following along. Alright, without further ado, let's go ahead and dive into it. Task 1, Introduction. This room expects you to be familiar with basic Linux command line functionalities like general system navigation and network fundamentals, which are ports, protocols, and traffic data. The room aims to encourage you to start working with Snort to analyze live and captured traffic. Before joining this room, we suggest you complete the network fundamentals module. If you have zero knowledge of network basics and Linux fundamentals, you will be ready to begin. If you feel you need assistance in the Linux command line, you can always refer to our Linux fundamentals rooms here, 1, 2, and 3, or you can just check out my channel and you can probably see videos of these already. Snort is an open source, rule-based network intrusion detection and prevention system, NIDS or NIPS. Here, it was developed and still maintained by Martin Roche, I'm not sure how you pronounce that, open source contributors, and the Cisco Talos team. The official description: Snort is the foremost open source intrusion prevention system (IPS) in the world. Snort IPS uses a series of rules that help define malicious network activity and use those rules to find packets that match against them and generate alerts for users. So we're going to complete that because we've already read it. Task number 2, interactive material and VM, which is virtual machine. Interactive material and exercise setup. Deploy the machine attached to this task. It will be visible in the split screen view once it is ready, which we can see here. If you don't see a virtual machine load, click the Show Split Screen button. Once the machine is fully loaded, you will see a folder named Task Exercises on the desktop. Each exercise has an individual folder and files. Use them accordingly to the questions. Everything you need is located in the under the task exercise folders. There are 2 subfolders available. So you have the config sample, which is the sample configuration and rule files. These files are provided to show what the configuration files look like. Installed Snort instance doesn't use them, so feel free to practice and modify them. Snort's original base files are located under etc Snort folder. Exercise files. There are separate folders for each task. Each folder contains PCAP, log, and rule files ready to play with. PCAP is packet capture, by the way, if you did not know that. So we have them right here, task files, or task exercises, so we're just going to get them loaded up here. Traffic generator, the machine is offline, but there's a script, traffic-generator.sh, for you to generate traffic to your Snort interface. You will use the script to trigger traffic to the Snort interface. Once you run the script, it will ask you to choose the exercise type and then automatically open another terminal to show you the output of the selected action. Note that each traffic is designed for a specific exercise. Make sure you start the Snort instance and wait until to end the script execution. Don't stop the traffic flood unless you choose the wrong exercise. Run the snort generator.sh file by executing it as sudo. So we're just going to copy and paste this over like so. All right, so we're going to open up a terminal here. And actually, I think we can just open it up in here. Yes, there we go. So it should be a lot easier. All right, I'm going to copy and then paste that in there. Okay, here we go. Then it says once you choose an action, the menu disappears and opens a terminal instance to show you the output of the action. So we can see that here, right? So when we start running this, it's going to look like something like this, like an actual packet capture. All right, so question time, navigate to the task exercise folder and run the command //easy.sh and write the output. So go ahead and pause the video and try that yourself, then come back to the video and we will continue on. All right, let's take a look here. I have my command ready to go. So I'm going to run this easy.sh script here, and it says too easy as the output. All right, so we're going to go ahead and copy this over and paste it here. Task number 3, introduction to IDS/IPS. So detection versus prevention. Before diving into Snort and analyzing traffic, let's have a brief overview of what an intrusion detection system IDS and intrusion prevention system IPS is. It is possible to configure your network infrastructure and use both of them, but before starting to use any of them, let's learn the differences. So first up is IDS. It says is a passive monitoring solution for detecting possible malicious activities / patterns, abnormal incidents, and policy violations. It is responsible for generating alerts for each suspicious event. Says there are two main types of IDS systems. You have network intrusion detection systems, NIDS. It says NIDS monitors the traffic flows from various areas of the network. The aim is to investigate the network or investigate the traffic on the entire subnet. If a signature is identified, an alert is created, and you have host-based intrusion detection systems, HIDS. HIDS monitors the traffic flow from a single endpoint device. The aim is to investigate the traffic on a particular device. If a signature is identified, an alert is created. Right, so the top one here, network based, and you have the other one here, host based, which is on the endpoint like your computer. And the next one is intrusion prevention system, IPS, is an active protecting solution for preventing possible malicious activity / patterns, abnormal incidents, and policy violations. It is responsible for stopping, preventing, terminating the suspicious event as soon as the detection is performed. There are four types or main types of IPS systems. Network intrusion prevention systems, NIPS. It says NIPS monitors the traffic flow from various areas of the network. The aim is to protect the network on the entire subnet. If a signature is identified, the connection is terminated. Before or behavior-based intrusion prevention system, network behavior analysis (NBA) says behavior-based systems monitor the traffic flow from various areas of the network. The aim is to protect the network or to protect the traffic on the entire subnet. If an anomaly is identified, the connection is terminated. Network behavior analysis system works similar to NIPS. The difference between NIPS and behavior-based is that behavior-based systems require a training period, also known as a baselining, to learn normal traffic and differentiate the malicious traffic and threats. The model provides more efficient results against new and unknown threats. The system is trained to know the normal to detect abnormal. The training period is crucial to avoid any false positives. In case of any security breach during the training period, the results will be highly problematic. Another critical point is to ensure that the system is well trained to recognize benign activities. So next one up is wireless intrusion prevention system, WIPS. WIPS monitors the traffic flow from and wireless networks. The aim is to protect the wireless traffic and stop possible attacks launched from there. If a signature is identified, the connection is terminated. HIPS, host-based intrusion prevention system. HIPS actively protects the traffic flow from a single endpoint device. The aim is to identify or investigate the traffic on a particular device. If a signature is identified, the connection is terminated. HIPS working mechanism is similar to HIDS. The difference between them is that while HIDS creates alerts for threats, HIPS stops threats by terminating the connection. All right, so if you just do a quick review up here, right? So detection versus prevention, you have the IDSs. Remember, this is like detect only, so it's not going to stop any type of malicious activity coming in. It's just going to detect it, say, hey, something funky is going on here. Here you go. Here's a fancy alert for you to investigate, and then it's up to you to go in and do your thing to respond to that. Whereas IPSs are going to not only detect the actual activity, but it's going to stop it as well. As you see, it can terminate the connection. All right, and you have different types as listed here, behavioral based, et cetera, et cetera. Now there's probably some even more fancy ones out there since AI is becoming more and more integrated into these products. So don't be surprised if you start seeing AI or artificial intelligence integrated into these products. Let's go ahead and continue on. Detection / prevention techniques. There are three main detection and prevention techniques used in IDS and IPS systems. So first one here, signature based. This technique relies on rules that identify the traffic patterns of the known malicious behavior. This model helps detect known threats. Behavior based. This technique identifies new threats with new patterns that pass through signatures. The model compares to known / normal with unknown / abnormal behaviors. This model helps detect previously unknown or new threats. You have policy based. This technique compares detected activities with system configuration and security policies. This model helps detect policy violations. Now, in the real world, you'll probably have a system that has a combination of these different mechanisms that can detect or prevent malicious activity. Maybe you'll have some old system that just does one or the other, but it's going to be different per environment that you're in. So I would just recommend knowing the different definitions of these and different types of IDS and IPS systems and their use cases Summary. Phew, that was a long ride and lots of information. Let's summarize the overall functions of IDS and IPS in a nutshell. IDS can identify threats but require user assistance to stop them. As I said earlier, it'll give you some alert. You have to go in and respond to that alert, investigate it and such. IPS can identify and block the threats with less user assistance at the detection time, but you have to be careful with this because you just don't want to go in and start blocking everything because you could block some legitimate traffic, all right? That's where this behavior-based one could come in handy if it's going in and doing a baseline and such, so it can try to tell you what traffic is normal as opposed to abnormal traffic. And then it can also help you detect any type of like new attacks coming, like perhaps 0 days activity or something like that. Now let's talk about Snort. Here is the rest of the official description of the Snorts. Snort can be deployed inline to stop these packets as well. Snort has three primary uses: as a packet sniffer like TCP dump, as a packet logger, which is useful for network traffic debugging, or it can be used as a full-blown network intrusion prevention system. Snort can be downloaded and configured personal and business use alike. So Snort sounds pretty versatile, right? Snort's been around for a long, long time and it's well known in the industry. Snort is an open source, role-based network intrusion detection and prevention system. It was developed and still maintained by Martin, open source contributors in the Cisco team. Capabilities of Snort: live traffic analysis, attack and probe detection, packet logging, protocol analysis, etc., etc., etc. You can see it can do all kinds of things here. Snort has three main use models. You got sniffer mode, read IP packets and prompt them in the console application. You have packet logger mode, and you have NIDS and NIPS. All right, so you can see there, pause the video, you can read the rest of the definitions there of the models that it uses. So question time. So I have quite a few questions here, so be sure, as usual, to pause the video, try to answer the questions yourself, then come back to the video, and then we will walk through them together. Hey everybody, welcome back to my channel. Be sure to hit the like button, comment, and subscribe. Once you subscribe, be sure to hit that notification bell. All right, so you know every time I post a new video. As you can see here, most people that view my videos, view my channel, are not subscribed. Now, if you do subscribe, it will help me get into the YouTube algorithm so that we can continue to grow our glorious community here. As always, thank you all for taking the time to watch. Have a nice day and enjoy the video. All right, let's take a look at these questions. Which IDS or IPS type can help you stop the threats on a local machine? Remember, they're talking about a local machine here. So that's the key word here, and that's going to be a host intrusion prevention system, or a HIPS for short. Right? So you want to stop the threats, not just detect them. So you want to stop the threats on a local machine. So remember that. Which IDS or IPS type can help you detect threats on a local network? Keywords here: detect threats, local network. All right, that's going to be a NIDS, or network intrusion detection system. Next one: which IDS or IPS type can help you detect the threats on a local machine? Once again, detect and local machine. That's going to be HIDS, host intrusion detection system. Which IDS or IPS type can help you stop the threats on a local network? Once again, you want to stop the threats on a local network, so that's going to be a NIPS, a network intrusion prevention system. Which described solution works by detecting anomalies in the network? Remember, that's going to be the NBA, which is the network behavior. What do they call it up here? There was the network behavior analysis one. Yeah, network behavior analysis. So let's go back down here. According to the official description of the Snort, what kind of NIPS is it? It's a full-blown one. Now this one may be a little bit troublesome to find, but it's in this paragraph here, right? Or in these this description here. It says used as a full-blown network intrusion prevention system. Next one is NBA training period is also known as baselining, as we saw above. Remember, it has to determine what traffic is normal so that it can determine what traffic is going to be abnormal once you put that into production or change it over into actual, blocking mode or what have you. All right, next one, task number 4, first interaction with Snort. The first interaction with Snort, first let's verify Snort is installed. The following command will show the instance version, so snort dash capital V. So let's go ahead and follow along here. Okay, and we have it installed here. It says version 2.9.7.0. Before getting your hands dirty, we should ensure our configuration file is valid. Here, dash capital T is used for testing configuration, and dash lowercase c is identifying the configuration file snort.conf. Note that it is possible to use an additional configuration file by pointing it with dash c. All right, so I'm just going to copy and paste like so. There we go. And it pulled back all kinds of information there. Snort successfully validated the configuration. Snort exiting. Awesome. Once we use a configuration file, Snort got much more power. The configuration file is an all-in-one management file of the Snort. Rules, plugins, detection, mechanisms, default actions, and output settings are identified here. It is possible to have multiple configuration files for different purposes and cases, but can only use one at runtime. Note that every time you start to Snort, it will automatically show the default banner and initial information about your setup. You can prevent this by using the -q parameter, which probably stands for quiet, and it explains the parameters and descriptions here. So -V or -- version parameter provides information about the instance version. -C identifying the configuration file. -T Snort's self-test parameter. You can test your setup with this parameter. And -Q quiet mode prevents Snort from displaying the default banner and initial information about your setup. That was an easy one. Let's continue exploring Snort modes. Question time. Be sure, as usual, pause the video, come back, and then we'll walk through these questions together. All right, so let's go ahead and find this one here. Run the Snort instance and check the build number, and we saw that above here, so I'm just going to scroll up. Actually, let's just clear the screen because there's a lot of stuff that came back here. And to get version number, you can use the -V here, and then here's our version here. So let's go ahead and copy and paste this over here. Actually, it said the build number, so that's going to be 149 right there. So 149, let's go ahead and type that in. And if my keypad works correctly, test the current instance with etc snort.conf file, and check how many rules are loaded with the current build. So let's go ahead and clear this out again. And then to do that, I'm just going to up arrow, right? And then check the snort here. As we ran that command from earlier with the test on it, so if I want to show y'all again, we can just up arrow. So let me clear all this stuff out here. And you can do the -C, right? Then we're going to target the snort.conf file, then -T to actually do the test. So you hit enter, and it's going to do all this stuff here. You have to scroll up a little bit to find the answer to this question, how many rows are loaded with the current build. So if we scroll up here, we can see that 4,151 snort rules. Okay, so that should be our answer. And the next one wants us to do it on the snort v2.conf file. So once again, we're going to clear all this stuff out again. Once everything's cleared out here, we're going to do the same thing here, except we're going to target this snort v2.conf file. Okay, hit enter. It's going to run, do its thing. Once again, you have to scroll up to find the answer to this one. So it says one snort rules red. So that should be our answer there. Test number 5, operation mode 1, sniffer mode. So let's see what they're talking about here. Let's run Snort in Sniffer mode. Like TCP dump, Snort has various flags capable of viewing various data about the packet it is ingesting. Sniffer mode parameters are explained in the table below. So parameter and description. -V, verbose, display the TCP IP. Output in the console. -D, display the packet data to the payload. -E, display the link layer TCP IP, UDP, ICMP headers. -X, display the full packet details in hex. And then -I. This parameter helps to define a specific network interface to listen/sniff. Once you have multiple interfaces, you can choose a specific interface to sniff. So let's start using each parameter and see the difference between them. Snort needs active traffic on your instance, so we need to generate traffic to see Snort in action. To do this, the traffic generator script, find this in the task exercise folder, which we saw earlier in this room. Sniffing with parameter -I, start the Snort instance in the verbose mode and use the interface eth0. So I'm going to copy and paste here. In case you have only one interface, Snort uses it by default. The above example demonstrates sniff on the interface named eth0. Once you simulate the parameter -V, you will notice it will automatically use the eth0 interface and prompt it sniffing with parameter -V. Start the Snort instance in verbose mode. So sudo snort -V. Now run the traffic generator script as sudo and start ICMP-HTTP traffic. Once the traffic is generated, Snort will start using or start showing packets in verbosity mode as follows. Right, so if we wanted to specify a interface, we can do it this way, and if we didn't want to do that, we just do it this way, and it'll automatically default to what's there. So let's go ahead and clear this out. All right, and then we want to generate a new tab because we have to run that script from earlier. So let's just do this sudo snort -v. Okay. Okay. Now we're going to run that generator from earlier, right? So let's see what it was. Yeah, there it is. I think you had to use sudo to run this. They wanted us to use sudo, so let's go ahead and try that here. And let's do this. Okay. Okay. Awesome. And let's go ahead and continue on here. As you can see, the traffic output verbosity provides TCP dump-like output information. Once we interrupted the traffic, Control C stopped it, summarized the sniff packets. All right. So they want us to run this ICMP and HTTP traffic here. So let's do this first. Okay. Let's take a look. All right. It looks like it's capturing. Let's go ahead and kill it with Control C. Okay, this is the end of it. So when we hit Control C, it'll tell you everything here. All right. So let's go ahead and clear this out. Let's try the HTTP one. So we're going to spin this up again, and then we're going to minimize this real quick just to get into the traffic generator. Okay, let's just go ahead and run it again. So we're going to scroll our up arrow, and we're going to do HTTP traffic this time. So go ahead and hit that. That's running. All right, so we should see all this being captured over here. So it's done now. So once you run it, you should be able to see what you saw when you generated that traffic, right? And we're going to continue on here. Sniffing with the parameter -d. Start the Snort instance, dumping packets, data mode -d. So let's go ahead and do that here. Clear this out. If I can spell sudo snort -d. Okay, there we go. And we should see something like this running in packet dump mode. It says now run the traffic generator script as sudo and start the ICMP slash HTTP traffic. Once the traffic is generated, Snort will start showing the packets in verbosity as follows. So once again, we're going to repeat here, run this again, and then it's going to generate this traffic here. So do it that way. Okay. Once this finishes, I'll run the HTTP one as well. So we're just following along. All right, so that's done running. So let's run this again, and then we will do HTTP traffic here. All right, once that's done, I went ahead and killed it. But as you can see that you can see more information using this -d than the original one up here with the -v parameter, and that's what they state down here. As you can see in the given output, packet data payload mode covers the verbose mode and provides more data. Okay, so we can start seeing some characters here as we scroll through here. All right, next one, we're going to use the -de. Okay, so start Snort instance, -d, and then the link layer header, grabbing -e, and then we're going to run those scripts again, ICMP, HTTP traffic. Once generated, Snort will start showing the packets in verbosity mode, and it's going to look something like this here. And the next one's going to be with the -x, right, for full packet dump mode, and run that script again, and they're going to see different outputs. So it's going to be based on use case, right? Using these different parameters and such. Okay, and let's just go ahead and try to run a few more of these, but I think you guys get the gist of it. So you're just going to be basically testing out different parameters to see which ones is going to give you the information that you're needing, right? So let's go ahead and clear this one out, and let's just play around with a couple of these here. Let's try this one here. So we got this one loaded up. Operation not permitted. Okay, well, that's because I didn't use sudo. So let's try this again. There we go. Now let's go ahead and run the script again. So let's clear this out. Up arrow, run ICMP, and then we're going to run HTTP next. Okay. All right, I'm just going to kill it here, and then we're going to run it again, just like so. There we go. Let it run for a little bit. Okay. Oops. Let me not do that. Hit cancel. So if we go back here, we're going to kill this. But once again, depending on which parameter you used is going to be which information you're going to get back. Okay. So you can go ahead and scroll through and then start reviewing the traffic that was generated and then determine which one may work for best or work best for you in whatever use case you're going to be using, right? So let's go ahead and continue on here. So make sure you understand and practice each parameter with different types of traffic and discover your favorite combination. You can practice parameter combinations by using traffic script, which we just did. So I recommend trying this on your own, playing around with these other ones as well. Task number 6, operation mode 2, packet logger mode. Let's run Snort in logger mode. You can use Snort as a sniffer and log the sniff packets via logger mode. You only need to use the packet logger mode parameters, and Snort does the rest to accomplish this. Packet logger parameters are explained in the table below. So let's go ahead and check out these parameters. -L logger mode, target log, and alert output directory. Default output folder is var log snort. The default action is to dump as TCP dump format in var log snort, and then -K ASCII logs packets in ASCII format, -R reading option. Read the dumped logs in snort -N, specify the number of packets that will process /read. Snort will stop after reading the specified number of packets. Let's start using each parameter and see the difference between them. Snort needs active traffic on your interface, so we need to generate traffic to see Snort in action. Log file ownership. Before generating logs and investigating them, we must remember the Linux file ownership and permissions. No need to deep dive into user types and permissions. The fundamental file ownership rule. Whoever creates a file becomes the owner of the corresponding file. Snort needs super user root rights to sniff the traffic. So once you run the snort with the sudo command, the root account will own the generated log files. Therefore, you need root rights to investigate the log files. There are two different approaches to investigate the generated log files. So you have elevation of privileges. You can elevate your privileges to examine the files. You can use the sudo command to execute your command as a super user with the following command, sudo command, as we've been doing. You can also elevate the session privileges and switch to super user account, examine the generated log files with the following command, sudo su for switch user. Change the ownership of files/directories. You can also change the ownership of the file/folder to read it as your user. So sudo then chown username file or sudo chown username -r directory. The -r capital R parameter helps recursive process the files and directories. Logging with parameter -l. First, start the snort instance in packet logger mode using sudo snort l -dev then -l. So let's go ahead and do that. Clear all this out. Paste. There we go. Let's see here what happened. All right, I forgot to put that dot at the end. There we go. Now start the script again. So I'm gonna up arrow, fire it off. Okay, while that's running, once traffic is generated, Snort will start showing the packets and log them in the target directory. You can configure the default output directory in snort.config file. However, you can use the -l parameter to set a target directory. Identifying the default log directory is useful for continuous monitoring operations. The -l parameter is much more useful for testing purposes. So let's go ahead and fire this off again using the HTTP traffic here. All right, the -l dot part of the command creates the logs in the current directory. You will need to use this option to have the logs for each exercise in their folder. Okay, so that's already done. Let's go ahead and stop this. Okay, and it's just showing us what we've already ran here. So if we had started this up, it'll tell you which directory it's pointing to. It's going to be this var log snort for that default one. Now let's check the generated log file. Note that the log file names will be different in your case, so you can use ls and then dot. So let's go ahead and try that out. So ls dot, there it is. So it should be this one here. Okay, as you can see, it is a single all-in-one log file. It is a binary / TCP dump format log. This is what it looks like. Folder view. Okay, log in with the parameter -k ASCII. All right, so we're gonna do the same thing basically, except we're gonna use this ASCII format. So if you want to do that, you can go ahead and run it yourself. I'm gonna copy and paste. So let's go ahead and clear all this out again. If I can spell clear, there we go. All right, so let's go ahead and paste this in there. All right, so it's running. Good to go there. Run the script again. All right, there's the first one. Now let's check the generated log file. Once again, we're gonna check and see that the log file is present on the machine. Folder view, and then the logs created. So let's go ahead and do the second one of this. Just HTTP traffic here. Okay. So this seems pretty straightforward, right? And let's see. It says the logs created with the -k ASCII parameter is entirely different. There are two folders with the IP address names. Let's look into them. So let's go ahead and stop this. Okay. And then you can do ls l, right? So you can see various different ones here, the IP addresses, since we use the ASCII one, right? And let's just try one here, I guess, and see what it says. Let's just try this first one. Copy this. Let me go ahead and clear this out. Okay, so ls. Okay. Permission denied, that's right. We have to use sudo. There we go. Once we have a closer look at the created folders, we can see that the logs are in ASCII and categorized format, so it is possible to read them without using a Snort instance. This is what it looks like in folder view. And once again, we have it pulled up here if you want to check a look at the folder view, okay? In a nutshell, ASCII mode provides multiple files in human readable format, so it is possible to read the logs easily by using a text editor. By contrast, the ASCII binary format is not human readable and requires analysis using Snort or an application like TCP dump, or maybe even, I guess, Wireshark would maybe work in this case. Let's compare ASCII format with the binary format by opening them both in text editor. The difference between the binary log file and the ASCII log file shown below, side by side. So you have binary format on the left and on the right side ASCII. All right, pretty straightforward. You're not going to be able to, this isn't human readable over here in binary as opposed to ASCII, it's human readable. Okay, pretty straightforward, folks. If you want to look at that, you can always go into one of these and take a look here. That's right. You got to open it as a root. But if you want to do that, you can try that on your own. I'm going to continue on here. Start the Snort instance in the packet reader mode. So let's go ahead and do that here. Right, so when you're using this -r parameter, be sure to point it at a file like so, otherwise it's not going to work. So I pointed at that file, went in, dumped it, or read it, I guess, and we have a similar format as up here. So if we scroll up a little bit, we can see everything here. So it was similar to what we were seeing in active when it was active listening to things, except it's in this actual file, right? So note that Snort can read and handle the binary like output. TCP dump and Wireshark can also handle this log format. However, if you create logs with the -k ASCII format parameter, Snort will not read them. As you can see in the above output, Snort read and displayed the log file just like in the sniffer mode, as I just stated. Open the log file with TCP dump. Okay, let's just follow along, I guess, and let's do TCP dump. Actually, let's go ahead and just clear everything out, just make things easier to read here. So sudo TCP dump, and then, okay, let's should have been this file here. Is TCP dump not on this machine or something? Let's try this again. Maybe I misspelled something. TCP dump. Okay, yeah, that's right. I had to put -r. I keep forgetting that. So paste that in there. And then we're going to use these dash NTC, I guess 10. Okay, there we go. It says you can open it with Wireshark. This is an example of what it looks like in Wireshark. So if you want to do that, go ahead and do that. In my experience, most of the time I'm using Wireshark to look at these packets if I need to look at packets. All right. It may differ based on whichever environment you work in or whichever tool you are most comfortable with. -r parameter also allows users to filter the binary log files. You can filter the process log to see specific packets with the -r parameter and Berkeley packet filters, BPF. So the different examples here, -x, ICP, etc., etc., etc. The output will be the same as above, but only packets with the chosen protocol will be shown. Additionally, you can specify the ports number of processes with the parameter -n. The following command will process only the first 10 packets, which we saw a combination there. So we had that -ntc, right? Let's see here. Snort -dvr log name log -n10. Please use the following resources to understand how the BPF works and its use. So be sure to check these out. Familiarize yourself with this process. Now use the task VM and navigate to the task exercise files, task 6 folder to answer the questions. Awesome. All right, so we have a couple of questions here to go through. So once again, pause the video, try to go through the questions yourself. As you saw, we played around with it a little bit, and hopefully you did on your side as well, and you should be able to answer the questions. So pause the video, go through these questions, then come back to the video, and then we will continue on. Let's take a look here. Investigate the traffic with the default configuration file with ASCII mode. So we're going to use sudo snort -dev -k ASCII-L, and then period at the end. So let's go and do that here, which I've already gone through this process, but I'm just showing y'all as we follow along. Execute the traffic generator script, task number 6. So navigate over there again, run it for task number 6 here. There we go. Let it run through all the way. Once that's finished, we're going to go to the folder named this here, and then we're going to see the source port connected to port 53. So it's done. Okay. Now we're going to go ahead and stop this. We don't need it anymore. So it's done. All right. So let's go ahead and clear this stuff out. ls, and then there's our folder right here. Okay. And then remember we have to use the sudo, so I'm just going to up arrow to get back to that point. Okay, there we go. So sudo ls and then the name of the folder, and don't forget the dot in there. That, and then we can see that UDP and then 3009, that the port's going to be 53. So that should be our answer there, 3009. Then it says use snort.log, yada yada yada. Read the snort.log file with snort. What is the IP ID of the 10th packet? So this is what we're going to be using to find that information here. So ls here. Okay, so first we need to navigate to the correct directory. So it's going to be in the exercise files, ls, and then task number 6 here. Task 6. Okay, ls right there. There we go. So I'm going to just copy and paste this over. Okay, don't forget your sudo, or you change the permissions of the file. It's easier for me to just do it this way here. Okay, there we go. And then when you find the packet ID, so if we go back down, since it was set to 10, we just look at the last one here. So let me scroll up a little bit here, and then we should be able to find that information. Here's the last packet here, or the 10th packet here, and the ID is right there. So 49313 is going to be our answer there. Next one, it says read the snorts.log of that file. With snort, what is the refer of the 4th packet? Now to get this one, remember it was talking about those different parameters we had to use. So we have to use that -x parameter. So I'm just going to hit the up arrow to find that particular command. And where is it? There we go. So you want us to get the 4th packet, right? So I have it set to 4 now, so we should be able to just look at the last packet to find the information, then the dash X so we can get that additional information in the packet. So let's go ahead and scroll back up here. And the right side here, as you're going through and reading through here, you'll see that the refer is going to be at the bottom. And it's going to be this www.ethereal.com/development.html. So that should be our answer there. Next one says read the same file. What's Snort? What is the ACK number of the 8th packet? So once again, I'm going to up arrow so we can find that information. All right, I think it was this one here. So let me scroll back up. Once again, set to 8. So the last pack is the one we need to look at in here. And there we go. There's the ACK, and then there's the number here. Right there. Okay. Next one says read the same file. Let's Snort. What's the TCP port 80? Now this one you have to use those filters as it was talking about here. So basically you have to replace this here. Okay. So once again, clear everything out. Up arrow, and I have that information. Okay. Let me find the correct history port here. There we go. TCP port 80. Right. So that's what we're looking for. Enter, and we should be able to see that information as we right here and the total 41. Okay, so using those filters, it filtered out everything else except for TCP port 80. Okay, let's go ahead and continue on to task number 7, operation mode 3 IDS/IPS. Snort in IDS IPS mode. Capabilities of Snort are not limited to sniffing and logging traffic. IDS/IPS mode helps you manage the traffic according to user-defined rules. Note that NIDS IPS IDS mode depends on the rules and configuration. Task 10 summarizes the essential paths, files, and variables. Also, task 3 covers configuration testing. Here, we need to understand the operating logic first, and then we will be going to rules in task number 9. So let's run Snort in IDS IPS mode. NIDS mode parameters are explained in the table below. So we see here dash C, configuration file dash T, testing dash N, disable logging dash D, background mode dash A, alert modes, full, fast, console, CMG, and none. So pause the video and read through these. Let's continue on. Let's start using each parameter and see the difference between them. Snort needs active traffic on the interface. Once again, you're going to use that script. Once you start running IDS IPS mode, you need to use rules as mentioned earlier. We will use a predefined ICMP rule as an example. The defined rule will only generate alerts in any direction of ICMP activity. So this rule is located here at C Snort rules local.rules. Okay. Remember this module, we will focus only on the operating modes. The rules are covered in tasks 9 and 10. Snort will create an alert file if the traffic flow triggers an alert. One last note, once you start running IDS mode, the sniffing and logging mode will be semi-passive. However, you can activate the functions using the parameters discussed in the previous task, so -E, -V, etc., etc., etc. If you don't remember those, the purpose of the commands, please revisit task number 4. All right, I'm assuming that we're going to be firing these off. I'm not sure if we're supposed to do this ourselves or just read through these. Let's go ahead and continue on. It starts talking about other parameters here, dash C, dash T. Start the Snort instance and test the configuration file here. Okay, so let's go ahead and just copy and paste this over. And let's go ahead and go back here. Okay, yeah, this should be the correct folder. Clear all this stuff out. Paste. Okay. This command will check the configuration file and prompt it if there's any misconfiguration in your current setting. You should be familiar with the command if you covered task 3. If you don't remember the output of the command, please revisit task 4. And then we're going to look at dash N. Um, disable logging by running the following command. So let's go ahead and do that here. It says now run the traffic generator script as sudo and start ICMP HTTP traffic. This command will disable logging mode. The rest of the functions will still be available if activated. So let's go ahead and paste this in here. Okay, there we go. So it's running, and we need to run the script again. So ICMP. So the command line output will provide the information requested with the parameters. So if you activate verbosity or full packet dump, you still have the output in the console, but there will be no logs in the folder. Okay, and then we're gonna run it again for HTTP traffic here. Basically, like I said, you're not gonna have a file that's logging this information, okay? It's just gonna be on the screen. Um, from my understanding of how this works, okay? So it should be done now. If we take a look here, there shouldn't be any additional logs from that, right? Because it's disabled. Dash D parameter. So we'll go ahead and copy and paste this again. All right, so clear all this out. All right, run the script again. What did that say? Make sure there's no errors. Let's see. Once the traffic generates, Snort will start processing the packets, accomplish the task by additional parameters. Okay. Okay, I guess that's how it's supposed to look. But let's go ahead and run this again. So we're just doing rinse and repeat here, just to show y'all how different parameters and different options work, et cetera, et cetera. So once this finishes, we'll run the HTTP part of it. All right, so that's done. So let's try the HTTP. Let it run. The command line output will provide the information requested with the parameters. So if you activate verbosity, um, full packet dump, packet logger mode, you will still have the logs in the folder, but there will be no output in the console. Once you start the background mode and want to check the corresponding process, you can easily use the PS command as shown below. All right, so I guess that part's done. So let's use another LS here, and then let's try this PS command here as they have it displayed. All right, there we go. Okay. If you want to stop the daemon, or I guess it's daemon, I don't know. Anyway, you can easily use the kill command and process ID. So if you want to stop it, you can use kill-9. Daemon mode is mainly used to automate the snort. This parameter is mainly used in scripts to start the snort service in the background. It is not recommended to use this mode unless you have a working knowledge of snorts and stable configuration. All right, so we're going to go ahead and kill this using the kill -9. Okay, -9, and then the process ID of it, which is going to be 2618, looks like. Done. Okay, and you can check it again. Okay, there we go. IDS IPS mode with the -A parameter. Remember that there are several alerts modes available in Snort. So if console provides fast style alerts on the console screen, CMG provides basic header details with payload in hex and text format. Full alert mode providing all information about the alert. Fast mode shows the alert message, timestamp, source, and destination IP along with port numbers, and none, disabling alerting. In this section, only console and CMG parameters provide alerts information in the console. It is impossible to identify the difference between the rest of the alert modes via terminal. Differences can be identified by looking at generated logs. At the end of the section, we will compare the full, fast, and none modes. Remember that these parameters don't provide console output, so we will continue to identify the differences through log formats. So IDS, IPS mode with the -A console. Console mode provides fast style alerts on the console screen. Start to Snort instance using this here. So we're going to go ahead and copy and paste as such. And we're going to clear this out. Okay, there we go. Now run the traffic generator again. All right. Once the traffic is generated, Snort will start generating alerts according to the provided rule set defined in the configuration file. Right. So it should be triggering on quite a few things here, it looks like. And then we're going to do the same thing for the HTTP traffic. So okay again, let it run all the way through. So once this is done, we should see some alerts. And there we go. All right, so let's see there. There we go. So you can go back up and sift through the information that was displayed here. All right, so we have similar output to the screen. Next one is the -A CMG. CMG mode provides basic header details and payload in hex and text format. Start the Snort instance once again. So we're going to use these parameters this time. So once again, clear all this junk out of here. Paste this over. There we go. And then it's up and running. Let's go ahead and run that script again. All right. Once the traffic is generated, Snort will generate alerts according to the provided rule set defined in the configuration file here. So we should see something like this, right? Let's compare the console and CMG outputs. So let's run this again for the HTTP traffic real quick. Before moving on to other alarms, as you can see in the given outputs, console mode provides basic header and rule information. CMG mode provides full packet details along with rule information, right? So if we go back and look here, it's exactly what we're seeing here. All right, so this looks good to go here. So we're gonna go ahead and kill this and clear the screen. Now we're gonna use -A fast, okay? It says there's no console output in this mode. Start the Snort instance, fast mode, okay? Copy and paste, and we're gonna run that script again, generate that traffic. All right, looks good. Okay, ICMP. Now run the Okay, that's done. So we should see something like this, right? Because we'll have to check the, I believe we have to check the log file, right? Since it's not displayed to the screen. So let's go ahead and run this second part of it, the HTTP traffic. Yeah, it says let's check the alarm file. Okay. Okay. Once again, it's not gonna display to the console here to the screen, right? It's gonna be in some file, alarm file somewhere. So if you want to use this mode, just note that you need to check the alarm file if you want to see activity and such. It says fast file contains summary information of action like direction and alert header. Next one is the -A for full. I'm just gonna skim through the rest of these here because we already know what they're gonna look like here, just looking at the pictures. But if you want to try this out yourself, go ahead and try these out yourself. So the -A in full, once again, it says there's no console output, and then this is how to run it. So once again, once you fire that up, run that script again to run the traffic for ICMP and HTTP, and it'll look something like this because once again, it's not going to be in the console. It's going to be an alarm file, and you should have output like this inside of there, right? As you can see in the given picture, full style alerts contain all possible information on action. Next one is -A none. Once again, no console output in this mode. This is how to run it here. And once again, run those scripts for ICMP, HTTP traffic. It's going to look something like this. Now, this time, it says that, as you can see in the picture below, there's no alert file. Snort only generates the log file. So it's going to look something like this, an actual .log file, right? And next one is using rule file without configuration file. It is possible to run these snorts only with the rules without a configuration file. Running the snort in this mode will help you test the user created rules. However, this mode will provide less performance. So once again, it's going to look something like this here. And this is IPS mode and dropping packets. Snort IPS mode activated with -Q DAQ AF packet parameters. You can also activate this mode by editing the snort.conf file. However, you don't need to edit the snort.conf file in the scope of this room. Review the bonus task or snort manual for further information on DAQ and advanced configuration settings using -Q DAQ AF packet. Activate the data acquisition DAQ modules and use this AF packet mode to use Snort as an IPS-I Ethernet 0, Ethernet 1. Identifying interfaces notes that the Snort IPS requires at least two interfaces to work. Now run the traffic generator script sudo. So basically just if you want to play around with this, feel free to. I'm just going to continue on here. As you can see in the picture above, Snort blocked the packets this time. We use the same rule with a different action, drop, reject. Remember, for the scope of this task, our point is to, or is the operating mode, not the rule, okay? And, okay, I guess that sounds pretty straightforward. All right, so we have some questions here. Be sure to pause the video and then go through these questions yourself and try to answer them, and then come back to the video. Investigate the traffic with the default configuration file, and basically just going to copy and paste this over. Then we're going to execute that script, but this time we're going to choose task 7. Okay, once that's done, we're going to need to find the number of detect HTTP get methods. So first off, let's go ahead and fire this up. Okay, it's running. Now, as soon as that fires up, we're going to go ahead and launch that script. And then right here, task 7 exercise, hit OK, let it run all the way through, and then we are going to stop Snort. All right, so that's done. navigate back over here and hit Control C to stop it. All right, so you're gonna have to scroll up a little bit, and then under these HTTP inspect encodings here, you can see get methods and to. So that should be our answer here. And then it says you can practice the rest of the parameters and use the traffic generator script. If you want to play around with it, feel free to do so. We are going to continue on in this video. Task number 8, Operation Mode 4, PCAP investigation. Let's investigate PCAPs with Snort. Capabilities of Snort are not limited to sniffing, logging, and detecting/preventing the threats. PCAP read investigate mode helps you work with PCAP files. Once you have a PCAP file and process it with Snort, you will receive default traffic statistics with alerts. Depending on your rule set, reading a PCAP without using any additional parameters we discussed before will only overview we'll only overview the packets and provide statistics about the file. In most cases, this is not very handy. We are investigating the PCAP with Snorts to benefit from the rules and speed up our investigation process by using the known patterns of threats. Note that we are pretty close to starting to create rules, therefore you need to grasp the working mechanism of Snorts, learn the discussed parameters, and begin combining the parameters for different purposes. PCAP mode and parameters are explained in the table below. So you have dash R or dash dash PCAP dash single equals read a single PCAP dash dash PCAP dash list read PCAPs provided in command space separated. PCAP show the PCAP name on the console during processing. Investigating single PCAP with parameter dash R. For test purposes, you can still test the default reading option with the PCAP by using the following command: snort dash R icmp-test.pcap. Let's investigate the PCAP with our configuration file and see what will happen. So I'm going to copy and paste this over. If you don't remember the purpose of the parameters in a given command, please revisit the previous task, come back again. So if you need to review that, go ahead and do that here, but I'm going to continue on. All right, I don't think it's stated where this test PCAP file was, but anyway, we're going to continue on. Just read through here. It says once our PCAP rule or ICMP rule got hit, as you can see, the following output: Snort identified the traffic and prompted the alerts according to our rule set here. So it should look something like that. And I went ahead and navigated to task 8 because there's a lot of files in here that we're probably going to be using here. And you can see that this is one of them apparently. But I wish it said this at the beginning of this particular task here. But anyway, investigating multiple PCAPs with parameter dash dash PCAP list. So same thing here. I'm going to copy and paste that over. Take a look at that PCAP file, and you can see the information displayed there. Since our ICMP rule got a hit, as you can see in the given output, Snort identified the traffic and prompted the alerts according to our rule set. Here's one point to notice. We processed 2 PCAPs, and there are lots of alerts, so it is impossible to match the alerts with provided PCAPs without Snort's help. We need to separate the PCAP process to identify the source of the alerts. So investigating multiple PCAPs with the parameter dash dash PCAP show. All right, so you can see here they're looking at 2 PCAP files here, test, and then this HTTP 2 PCAP file, right? And they want to show the information here, and it should look something like this. Okay, and it's just the same thing here. You got a hit, yada yada yada. Now use the attached VM and navigate to task exercises, exercise task 8 folder to answer these questions, which I've already done here. And there's a lot of questions here, so be sure to pause the video, go through these questions, then come back, and then we will continue on. You can also play around with it too, right? So if I wanted to just fire this off and see, right? So there you go. Investigate the MX-1 PCAP file with the default configuration file. So let's go ahead and fire this off and see if we can find out. First one says, what is the number of generated alerts? Now, if we scroll back up here, we start talking about alerts. Action stats alerts going to be 170. So that's our answer there. Keep reading output. How many TCP segments are queued? And we could find that as we scroll down here, and it should actually say TCP segments queued. So we see that here, TCP segments queued, 18. That's our answer there. Keep reading output. How many HTTP response headers are extracted? So it's going to be further on down here. HTTP response headers extracted right there, 3. Okay, next one says to investigate the MX-1 PCAP file with the second configuration file. So let's go ahead and clear this out. Once again, paste this in there, let it run. And now we need to find the generated alerts. And so we have to scroll back up a little bit here. Action stats, alerts 68. So there's our answer there. And then The next one says investigate the MX2 PCAP with the default configuration file. What is the number of generated alerts? Once again, it should be in that same section. So let's go ahead and paste this in there. And we'll sift through again to that stats section. So scroll back up. There you go, action stats, alerts 340. So there we go there. Keep reading the output. What is the number of detected TCP packets? Now, to find this one, you can scroll up a little bit here, and you can see that where it says breakdown by protocol. So you can find it here under TCP. It says 82. All right. So that's our answer there. And the next one says investigate MX2 PCAP and MX3 PCAP with the default configuration file. So once again, clear this out here, paste it in there, let it run, and then we'll go back and take a look. So it's asking about alerts again. So we have to scroll up a little bit again to get to that section. There we go here, action stats, alerts 1020. So there's our answer there. Task number 9, snort rule structure. Let's learn snort rules. Understand the snort rule format is essential for many blue team and purple team. The primary structure of snort rule shown below. So it looks something like this here. You have action, protocol, source IP, source port, direction, destination IP, destination port, and options. All right. So pause the video and read through this here. All right. Each rule should have a type of action, protocol, source and destination IP, source and destination ports, and an option. Remember, Snort is in passive mode by default, so most of the time you'll use Snort IDS. You will need to start inline mode to turn on IPS mode. But before you start playing with inline mode, you should be familiar with the Snort features and rules. The Snort rule structure is easy to understand but difficult to produce. You should be familiar with rule options and related details to create efficient rules. It is recommended to practice snort rules and option details for different use cases. We will cover basic rule structure in this room and help you take a step into snort rules. You can always advance your rule creation skills with different rule options by practicing different use cases and studying rule option details in depth. We will focus on two actions: alert for IDS mode and reject for IPS mode. Rules cannot be processed without a header. Rule options are optional parts. However, it is almost impossible to detect sophisticated attacks without using the rule options. So that sounds very important. All right, so action, there are several action for rules. Make sure you understand the functionality and test it before creating rules for live systems. The most common actions are listed below. So you have alerts, generate an alert, and log the packet. Lock the packet, drop, lock in, log the packet, reject, block the packet, log it, and terminate the packet session. Protocol parameter identifies the type of protocol that the um, that filtered for the rule. Note that Snort2 supports only 4 protocols filters and the rules: IP, TCP, UDP, and ICMP. However, you can detect the application flows using the port numbers and options. For instance, if you want to detect FTP traffic, you cannot use the FTP keyword in the protocol field, but filter the FTP traffic by investigating TCP traffic on port 21, IP and port numbers. These parameters identify the source and destination IP addresses and associated ports and numbers for filtering the rule. All right, so be sure to pause the video and read through all this yourself here. I'm just going to skim through it. So you have IP filtering, filter an IP range, filter multiple IP ranges, exclude IP addresses, ranges, port filtering, exclude a specific port, filter a port range, etc., etc. So it could do all kinds of stuff. Seems pretty versatile here with the rules. Direction operator indicates the traffic flow to be filtered by Snort. The left side of the rule shows the source, and the right side of the rule shows the destination. So this one is the source to destination flow, and then this one is bidirectional flow. You'll notice that there is no less than dash operated in Snort. So if we take a closer look here, we see what they're talking about here: rule header, source, destination, and then this is right here, right? So this is bidirectional flow, and then the rule options. All right. There are 3 main rule options in Snort. So you have general rule options, fundamental rule options for Snort, payload rule options, rule option that help to investigate the payload. These options are helpful to detect specific payload patterns. Non-payload rule options that focus on non-payload data. These options help create specific patterns and identify network issues. General rule options. Alright, so once again, be sure to pause the video. I'm going to skim through this. So MSG, the message field is a basic prompt and quick identifier of the rule. The SID, Snort's rules IDs SID come with a predefined scope, and each rule must have a SID in a proper format. So reference, each rule can have additional information or reference to explain the purpose of the rule or threat pattern. Rev, Snort rules can be modified and updated for performance and efficiency issues. Payload detection rule options, content, payload data. It matches specific payload data by ASCII, hex, or both. It is possible to use this option multiple times in a single rule. However, the more you create specific pattern match features, the more it takes to investigate a packet. No case, disabling case sensitivity, fast pattern, the following. Prioritize content search to speed up the payload search operation. By default, Snort uses the biggest content and evaluates it against the rules. Okay, non-payload detection options. There are rule options that focus on non-payload data. These options will help create specific patterns and identify network issues. So ID, filtering the IP, ID field. You got flags here, filtering TCP flags, D size, same IP. So remember, once you create a rule, it is local. It's a local rule and should be in your local.rules file. This file is located under etc snort rules local.rules. A quick reminder on how to edit your local rules is shown below. So if you want to use sudo gedit etc snort rules local.rules, okay, or use any other text editor, right? So that's what gedit is. It's a text editor. Um, that is your local rules file. All right. So if you want to take a look at this here, let's see if it actually works on here. So let's go ahead and clear all this out, then paste this in. Okay, there we go. Note that there are some default rules activated with Snort instance. These rules are deactivated. To manage your rules and improve your exercise experience, for further information, please refer to Task 10 or Snort Manual. By this point, we covered the primary structure of the Snort rules. Understanding and practicing the fundamentals is suggested before creating advanced rules and using additional options. Wow, we've covered the fundamentals of the Snort rules. Now use the task VM and navigate to the task exercise files, task 9 folder to answer the questions. Note that you can use the following command to create the logs in the current directory -L and then the period at the end. Answer the question. So once again, pause the video, go through the questions, and then come back to the video, and we will continue on. Okay, let's go through these questions here. Use task9.pcap, write a rule to filter IP ID 35369 and run it against the given PCAP file. What is the request name of the detected packet? You may use this command, snort-c local.rules-capital A full-L -R task9.pcap. All right, so basically what you're going to do is you're going to read through all these questions here and you're going to edit this local.rules file, right? And we're going to use everything that we learned in this particular section here, right? So if we go back, take a look at how these rules look like and such. So it's going to look like something like this, okay? And you'll see that here in a minute as we go through this .rules file. So the first one here, let's go ahead and try to get that. I've already have mine commented out, as you can see there. So let me go ahead and comment this one out. And then this is the first one here, right? Okay, so we have the ID that we're looking for here, this 35369, and you can see that it's ICMP any, and this is bidirectional according to what we saw above in the room here. Everything looks squared away. The SID is listed out here. Okay, so we're gonna go ahead and save this file, and then we're gonna close this out, and then we're gonna run this right here, this command and parameters and such. So I'm just gonna copy and paste this, and we're gonna run this against that PCAP file. Okay, it's going to go through, do its thing here. Now after it's done, what you can do is ls, you can see that there's a alert file there. So we're going to cat that to see the contents. Actually, we can just use a gedit on it. Bring it up here, okay? And we can see that it says time stamp request right there. That's what we're looking for here. So it says, what is the requested name of the detected packet? It's going to be time stamp request. So we're done with that. Now we have to go in and clear this out. They want us to clear this out every time you go through and go to a different area here or a different question here. So we're going to go ahead and clear all this stuff out. Save it. Now it's a blank file. You can also just delete it if you want to, but I'll just go ahead and clear it out. Now we're going to go in and we're going to go ahead and gedit local rules again, because this next one says clear the previous alert file, which we just did, coming out the old rules. Create a rule to filter packets with SYN flag and run it against the given PCAP file. What is the number of detected packets? Okay, so we're going to go ahead and comment this out, and this is our second one here. So we're going to go ahead and save this, and we can take a look at this again. Looking for SYN, we have this designated as TCP any bidirectional any flags set to S for SYN. We have the SID listed here. Okay, so we're going to go ahead and exit out of this since we have already saved it, right? So we're going to go ahead and run that command again that we saw earlier, like so. It's going to go through and we need to find what is the number of detected packets. So if we go scroll up a little bit here, we see action stats, alerts is just one. So that should be our answer here. And if we go and continue on, the next one says, once again, clear it out again. This time it says, write a rule to filter packets with push ACK flags and run it against the given PCAP file. What's the number of detected packets? So once again, we're going to clear all this stuff out. We're going to go ahead and edit that, that alert file. Go ahead and delete all this stuff out. Control S to save it, and then we're going to close this out. And then now we're going to go to our rules again. Okay, we're going to go ahead and comment this out like such. Clear all this out here. All right, so once again, alert, TCP, any, bidirectional, any for destination. And we have the flag set to PA because we're looking for this push ACK flag, right? And then there's a SID for this particular rule, right? Like I said, you're going to use everything you learned in here. So you can see that there's a different flags we have set inside of here, right? And we can see that the ID is going to look something like this, right? So there you go. In case anyone's confused here, that's exactly what we're doing. And we're just following along what they had showed earlier. So we're going to go ahead and save it and close it out. Once again, we're going to run that command here. So I'm up arrow because I'm lazy. Run it against here. And now it should run and do its thing here. We can see that the number of detected packets is going to be here under action stats, alerts. We got 216 for that. So next one, once again, clear out that alert file. Then now we're going to create a rule to filter UDP packets with the same source and destination IP run against the given PCAP file. What is the number of packets that show the same source and destination address? All right. So once again, go ahead and clear this stuff out, and we're going to edit this file again. Clear all this stuff out of here. So we have a nice and clean alert file here. Hit the X there, and now we're going to edit our rules like so. And I'm going to comment this out because we're going to use this last one here. Okay. And you can see how I have it set here, IP any. This time it's going to it's pointing towards the destination. It looks like here, sample IP or same IP, and then there's the SID for it. So we go there. We're going to save it, and then we're going to run it again. Call this out. Okay, let it run through there. And now we got to take a look at, I believe, that alert file. This one is a little bit tricky because you have to go in, take a look at this file, right? But you have to filter out or ignore broadcast addresses. These other ones have all zeros in there. You have to ignore all those, and whichever ones don't look like this here, that's the ones you're going to count inside of this particular file. And there should be 7 inside of here, right? As you sift through here. So there's 1 right here, right? 2, 3, 4, 5, 6, and there should be a 7th one in here. Let's see. It's not displaying. I think this is the last one. Let me get rid of some of this stuff first. Maybe it'll be easier to read. Let's delete all this junk out of here. Okay, now let's scroll down again. Still can't see it, so let's delete all the stuff we don't need inside of here. All right, let's delete this. Okay. I think we are good to go here. So 1, 2, 3, 4, 5, 6, and then I believe this is the 7th one. Yes, 7. So there you go for that one. The last one here is case example. An analyst modified an existing rule successfully. Which rule option must the analyst change after the implementation? Now this is going to be rev for revision. So if we scroll back up here, or let me just try this. Might be easier to find. Yeah. But yeah, you can see that it says rev1, et cetera, et cetera. Anytime you change it, you have to update that number. Okay, so that wraps up that particular section, and you can see how it's referenced here. Snort rules can be modified and updated for performance and efficiency issues. Rev option helps analysts to have the revision information of each rule. Therefore, it will be easy to understand rule improvements, et cetera, et cetera, et cetera. All right, so there you go for that one. Next task is task number 10. It says snort to operation logic, points to remember. All right, I don't think there's any practical application here, so I'm going to minimize this here. Points to remember, main components of snorts. Do you have? I'm going to skim through all this because I think this is just a bunch of reading here. So feel free to pause the video and read this yourself. I'm just going to skim through it. All right, so main components of Snort, you have the packet decoder, packet collector component of Snort, collects and prepares the packets for pre-processing. Preprocessors, component that arranges and modifies the packets for the detection engine. You have the detection engine, logging and alerting, outputs, and plugins. There are 3 types of rules available for Snort: community rules, free rule set under the GLP version 2, publicly available, accessible, no need for registration. You have the registered rules, subscribe rules, which is paid rules. You can see there. It says you can download and read more rules here. Note, once you install Snort 2, it automatically creates the required directories and folders or files. However, if you want to use the community or the paid rules, you need to indicate each rule in the snort.conf file. Since it is a all-in-one configuration file, editing it without causing misconfiguration is troublesome for some users. This is why Snort has several rule updating modules and integration tools. To sum up, never place your configured Snort configuration files. You must edit your configuration files manually or update the rules with additional tools and modules to not face any fail/crash or lack of feature. So you have the snort.conf main configuration file. You have the local.rules user generated rules file. All right, it says overview. The main configuration file is located here. So sudo gedit etc snort.conf. So you can take a look at that if you want to. Navigate to the step number 1. Set the um, network variable section. All right, I believe that I guess we're supposed to do this. So let me bring this back down here. So show splits view. And we're just going to take a quick look here. I'm not going to go through all these, but y'all will get the gist of this. So let me go ahead and, yeah, close out, save, and whatever. So we're going to go ahead and do gedit. Okay, I don't think it copied correctly, so let's try this again. Okay, so Control C. All right, now let's try this. There we go. All right, and there's a bunch of information here, it looks like. So number 1, set the network variables, right? And since this section manages the scope of the detection rule paths, you can see the table here, tag name, info, example, home underscore net, external underscore net, et cetera, et cetera. Navigate to step 2, configure the decoder section. In this section, you manage the IPS mode of Snort. There's information about that here in this table. Data acquisition mode or modules, DAQ, are specific libraries used for the packet I/O. Bringing flexibility to process packets, it is possible to select DAQ type and mode for just different purposes. There are 6 DAQ modules built for Snort, and they're listed out here: PCAP, AF packet, IPQ, etc., etc. The most popular modes are the default PCAP and inline IPS. Navigate to step 6, configure output plugin section. This section manages the outputs of the IDS IPS actions, such as logging and alerting format details. The default action prompts everything in the console application, so configuring this part will help you use the Snort more effectively or more efficiently. Navigate to step 7, customize your rule set. So we have the tag name, info, example, number of site specific rules, include rule path. Note that the pound is commenting operator. You should uncomment a line to activate it, as we saw earlier when we were messing around with that alert file or the rules file, right? Like I said, there's a lot of information here, and this is what they're talking about here. So you can, well, these are telling you like what this specific area is about. But yeah, so feel free to go through here and take a look at this particular file, get familiarized with it, also with the information that's covered over here. Okay, so we're done with that. And we're going to wrap up this video with the conclusion, task number 11. In this room, we covered Snort, what it is, how it operates, and how to create and use the rules to investigate threats. Understanding and practicing the fundamentals is crucial before creating advanced rules and using additional options. I mean, this is what pretty much every tool out there, you need to have an understanding of it and how to apply it to your particular use case. Do not create complex rules at once. Try to add options step by step to notice possible syntax errors or any other problem. Easily do not reinvent the wheel. Use it to modify slash enhance it if there is a smooth rule. Take a backup of the configuration files before making any change. That's very important here. Okay, very important here. Take a backup of your stuff because if you don't and you end up jacking up something, now you don't have a place to revert back to a known configuration that was working properly, right? Never delete a rule that works properly. Comment it if you don't need it, as we did earlier with that locals rule file, right? Test newly created rules before migrating them to production. Now we invite you to complete the Snort Challenge room. Snort Challenge live attacks. That's probably like the next room, I believe. I'm not sure. A great way to quickly recall Snort rules and commands is to download and refer to the TryHackMe Snort cheat sheet. It looks like this here. I'm assuming that's what this downloads task files is for, but it's got a lot of information here. Looks like a quick like cheat sheet reference sheet you can use to build out Snort rules or use Snort in general. All right, so we're done with this and we're done with this room. If you enjoyed this video, if you found it valuable, be sure to like, comment, and subscribe. Helps out the channel, helps get the word out there, helps continue to grow our community. Now, I recommend taking a look at this room, going through it again, check out the video again, what have you. Anything that can help you progress in your career, get you familiarized with tools such as Snort, right? So be sure to get that hands-on keyboard experience, that skill set, because you might use Snort in an organization that you happen to work for. But anyway, thank you all for taking time to watch my video. Have a nice day, and I will see you later.